Hello guys, in this video I'm going to show you how to solve target sum using dynamic programming with bottom-up approach. Right? In the last video we solved it in top-down approach, but let's go through the problem statement once again. So you're given a set of positive numbers and a target sum S. Each number should be assigned either a plus or minus sign. We need to find the total ways to assign symbols to make the sum of number equal to target S, right? Okay. So for this given input 1, 1, 2, 3 with target sum is 1, how many ways that we can assign symbols to make the numbers equal to the target sum? So there's 3 ways here, as you can see, to end up with 1, right? So it is just different ways of putting either plus or subtract, plus or minus sign, right? In front of each number. So there are 3 ways. Like for example, this one, 1 plus 1 plus 2 is 4, minus 3 is 1, right? Equal to target sum here, right? So in the last video we've solved it in like using brute force, right? Using brute force with this problem is a kind of top-down, right? Top-down approach. But for bottom-up approach, we want to use two-dimensional tables. Want to solve subproblems first, and then wanna gradually build up a two-dimensional table. And the final step is when we get the answer for the final questions here, the original questions here. So the important things now is to modelize this problem into we must determine a way to modelize it, and how wanna use two-dimensional table here, right? So let's see. Okay, probably one way could be it's like pretty similar with some previous problem, right? So probably the target sum here, the column could be from 0 to target sum 1 to 0, for example, and the row could be all the each row will be, each row want to consider one number from the input. So we have 4 rows, 1, 1, 2, 3, right? So it will be very easy if if we just uh, sum up all the numbers and to like compare with target, right? But here, like for each target sum here, it could be different. It could be either minus or plus, right? So there are huge amount of cases we need to consider if we go about this approach, right? But let's see if we can um, if we can simplify this problem into the one that is similar to us, right? The one that is similar to problems that we've already solved. So let's take a look at one result, one possible combinations here. So for example here, it is actually could be for this case. For example, let's uh, this one is actually can be written into another form, which is 1 plus 3 minus. These can be grouped and wrapped in a parenthesis. Okay. So it would be 1 plus 2, right? So this one is the same, can be grouped in the same way here. 1 plus 3 minus 1 minus 2 can be grouped into this. Like for this one, it's the same. Could be, like for example, like it would be 1 plus 1 plus 2 minus 3, right? So in general, it would be a combination here will be a can be written into can be written like a minus b, right? Whereas a is a subset from the input, and also b is a subset from the input also, right? So a minus b here will equal to what? To the target sum, right? But as you can see here, um, the relationship between A and B, if it's two different subsets, and each subset, like if we combine two subsets together, it's gonna be the original input, right? So another conclusion that we can make here is A plus B is what? Is a sum, right? Sum here means sum of all the input. Like for example, in this case, it would be 5 plus 2 is 7. Right? This something can be calculated here. So from these two pieces of information, what we can conclude here is, like, if we take left side of first expressions plus left side of second expressions, it would be minus b plus b is 0. So we left with 2a, right, equal to target sum plus sum, right? So it would be a equal to target sum plus sum uh, divided by 2. And actually target sum here is this given s, right? And sum here is a sum of all the number, right? So now our original problems can be translated into this problem, which is uh, can we find a subset? A here is actually a subset from this given input that sum up to this, which is can be calculated, right? Okay, so this one is actually the same as the subset sum problem, I guess. Not sure. I think it's very similar one, right? So maybe I'm not gonna show you. We're not gonna solve it manually, right? So this one we'll use it now. So let's get into coding, right? This actually this uh, observations is pretty much like 80% of this problem, right? If we can come up with this problem become easy. Okay, so first thing we need to calculate here is the sum, right? So that's sum. We need to sum up all the numbers in this array. So I will use array of the reduce. It'll be a, b. So let's do it quick here. This will return the sum of all number in the array. Okay, next we need to find the new target here, right? The new target of this problem, right? And here is a new target that we need to find. It will be sum plus target divided by 2, but this I'm gonna use method for. Okay, is decimal number. Okay, here's a new target. Our problem now is like how many count subsets this given input that sum up to new target. Okay, whoops. So for this one Okay, our table will be, like for example here, let's say the sum here is 7, right? 7 plus the target is 1 is 8. 8 divided by 2 is 4. So the new target is 4. So the column will be from 1 to 4. 1, 2, 3, 4. The row will be each number from the given input, right? So here will be our two-dimensional table. So the number of rows will be array.length, and number of columns will be new target plus 1. Like for example here, the target is 4, new target is 4, so the number of columns will be 4 plus 1 is 5, because we need to consider 0 as well. So I will abstract the logic of creating a two-dimensional table into a functions. It will be dp create matrix passing rows and columns. I'm going to do it right away here. Create matrix, text in rows and columns. This will return a two-dimensional matrix. So I'm going to use first array of number of rows first, right? So I'm going to fill it with whatever. For example, no here. Don't care, because I will map each node into another array inside, so that we can have two-dimensional table. Array here will be number of columns, and now I will map it to 0, right? So the value of each cell here will be the answer for questions. How many ways, how many subsets from the current from the given from a given input, right? A sum up to the target. Okay, so want to initialize is cell with 0, because initially assume that there's no ways, right? Because initially we don't know yet, so it will be 0. But later, when build up our table, so let's double check it here. So I will create a matrix 4 and 5, for example. No, I will map it. Okay, stack. No, I don't use map here, but fill instead. Fill it with 0. Again, whoops. Matrix arrays is not functions. What wrong here? Oops. Map each item into arrays. Again, okay. 3 row. Each row had 5 columns. So we're done with these functions. So let's get into So for two-dimensional table, because this is kind of uh, bottom-up approach, so we need some kind of base case, like some initial cases that we assume that we know the answers. So in this case, it would be first column. So we assume that uh, from any given input here, there will be one way to find subset sum up to 0. It would be a empty subset, right? So it will be 1, 1, 1, and 1. So first column, we'll click here, last row of DP, and first row will be 1. Okay. Next would be first row. So the only value that is the only thing, the only cell that we want to assign value here is the cell that has row equal to column, right? So because like for each row, for this row, we're considering input of 1, right? Nice. So here, there's only this row that we can find a subset that sum up to 1, which is actually this one, right? So it'll be that's one way, but for 2, 3, 4, there's no way to find a subset from 1 to sum up to any number from here, right? Okay, so it'll be all 0. So so from that observations we can assign no, dp first row uh, with column is equal to row, right? So the first row would be is actually this value, so it would be array at index 0. So this will be 1. Okay. So from now, I'm gonna start building up, filling up our table. So I'm gonna start from row 1 and column 1. Okay. Oh, okay. So let's see. So for each cell here, right? Generally, we have two choices, which is either take the current number, which is here. For example, we are here. We're trying to fill this x, right? So there will be two ways, which is either take this one into our subset, right? Or want to skip this one. If we keep this one, the value would be the cell right above. So the current number we are considering here is actually the array at index row. Okay, choice one is we skip kernel. So it would be dp at row and column will be, I will add up with the value of the cell right above, which is dp row minus 1 column. Okay, choice 2 is we take this one, but important thing is we only want to take the current number if the current target is greater than or equal to this current number. Because if the number that we want to take into our subset is even greater than the target, so it will make no sense to, because we're trying to find a subset that sum up to the target, right? So here only one we take column. Okay. If the column is greater than or equal to column, I will consider to find way to update it here. Okay, so if I take this one, I can take the target sum. It means I will subtract the current num from the current target, right? So our problem is simplified, and like for example, this guy 1 minus 1 is 0, right? So now problem now is how many ways, count the ways to find subset that sum up to 0, because we take one here, so we want to exclude one here. So the result can be found here in target 0 and with this one on. So it would be okay, dp row minus 1 because we exclude the current number, and the column minus kernel, right? Okay, so at the end, if we find the final value here, it is actually the original problem, which is considering 3211. How many ways we can find, how many subset we can find sum up to 4 here. Okay, so I just return the last value, bottom right corner, which is would be dp rows minus 1 and column minus 1. Yeah, I think that is it. test. Just continue and wait. Okay, it works. Okay, let's double check it here. Oops. Okay, not sure. See the test bottom up here. Three tests. No, it should be six instead. Okay, we're failing test. Now, hopefully it will work. Okay, it works. So that is it for target sum using bottom-up approach, right? Dynamic programming with bottom-up approach. So that is it for this video. Thanks for watching. See you in the next one.